Hey guys, time to start another unit. This unit's all about factoring. So this section 2.1 is about a few simple factoring techniques. You've hopefully seen some of them before, but if not, we're going to get a good refresher right now. So first I want to define what factoring is. So factoring is taking something bigger and breaking it out into smaller chunks. It's kind of the idea of it. So you've seen factoring a lot with integers actually, even if it wasn't called that. You might have seen like a factor tree. So like say I wanted you to factor the number 30, you would start dividing 30 into two things that multiply to give you 30. So for example, if I do 5 times 6, I get 30. So you would say that 5 and 6 are factors of 30. And then I can factor 6 even further to say that 2 multiplied by 3 gives you 30. Oh, sorry, 2 multiplied by 3 gives you 6. So 2 and 3 are factors of 6. And then this 5 and this 2 and this 3, they are all prime numbers, which means that they don't have any factors besides 1 in themselves. So we would say that 2 times 3 times 5 is the prime factorization of 30. Okay, we've broken it down as far as we can. And 2 times 3 times 5 is equal to 30. So when we talk about factoring polynomials, we're going to be doing a similar thing. We're going to be taking a big, long polynomial and breaking it down into little smaller polynomials like this 2, 3, and 5 that would multiply to give us the big polynomial we started with. So let's take a look at one way that this is possible. So one thing that we can do is we can factor out the greatest common factor. That's sometimes called the GCF. And this is probably the easiest way to factor. So let's just take a look at that with a simple polynomial like x squared plus 3x. So to factor out the greatest common factor, we basically look at the two terms in our polynomial, the x squared and the 3x, and we look at what they have in common. And in this case, we notice they both have an x in them. So we can take out an x. So we factor an x out of the polynomial. When we factor an x out, then we know if we divide the x squared by x, we're left with just x, and if we divide the 3x by x, then we're just left with 3. So this would be one way to factor the polynomial. You can always check your work with polynomials, with polynomial factoring, by going back and multiplying. So if I would like to distribute this x back inside my parentheses, like we did in the last unit, I would get x squared plus 3x, which is what I started with. So that means that I did, in fact, factor right. So factoring is super easy to check because you can just multiply back. But this right here would be the factored version of the polynomial. So let's look at one that's a little bit messier. Let's say I have negative 2a squared b cubed plus 8, a to the 4th, b to the 8th, minus 6a to the 3rd b. Yikes, that is one messy thing. So we want to start by trying to figure out what all of these terms of the polynomial have in common. So I'm going to look at each type of component of the term individually. So I'm going to look at the constants, and then the a variables, and then the b variables. So let's look at just the constants. My coefficients are negative 2, 8, and 6. And I notice that all of those are divisible by 2. So we would say that 2 is a common factor of all of those. So I'm going to factor a 2 out of each of those. In fact, I'm going to factor a negative 2 out. And the reason I'm going to is because then that gets rid of my negative on the front of my polynomial. I'm not a huge fan of those on the front. So I'll factor out a negative 2. And let's see what I have left if I factor out a negative 2. So I'm just going to rewrite the polynomial, but just the coefficients. So if I factor out a negative 2 from the first term, I'm left with just a 1. I'll leave some space for the other parts of the term. If I factor out a negative 2 from the 8, I'm left with a negative 4. You might ask how I'm doing that. I'm basically saying 8 divided by negative 2 is negative 4, and that's the number that is left over. And then negative 6 divided by negative 2 is 3, so I'm going to have a plus 3 here at the end. Okay, so now I'm kind of factored out my constants. Now I need to take care of my a variable. So let's see how many a's I have in common. I've got a squared in the first, a to the fourth in the next term, and a to the third in the last term. So I can only take out the smallest number of a's. So in this case, I can take out an a squared, right? That lets my first term basically have no more a's in it because I took all of them out. My second term is going to have an a squared left in it because if I have a to the fourth power and I divide it by a squared, I'm left with a squared. And then a to the third power, if I divide out the a squared, I'm left with just an a to the first power. Okay, final step is seeing how many b's I can take out. In this case, my last term only has one b, which means that I can only take out one b from all of these. So my first term is still left with a b squared, my next term is left with a b to the seventh, and then my last term is left with no b's. So this would be, excuse me, one way to factor this polynomial. What we've done here is we've factored out the greatest common factor. So we would call this term out here that we factored out the greatest common factor, the GCF. And as we can see in this one, it can be a combination of constants or variables. It can be positive, it can be negative, whatever works to get the most, to basically factor out the most things, the most terms. Okay, we're going to take a look at another kind of factoring. In this factoring, we're going to go from a trinomial, and I'll explain what that is in a second. We're going to go to two binomials. Okay, so remember how we talked about before that nomial, that part of the word, nomial means term, and tri means three. So trinomial means that I'm dealing with a polynomial that has three terms. So three terms. Similarly, a binomial means two terms. So I'm basically going to take one set of parentheses that has three things in it and turn it into two things, into two factors, two binomials. So let's take a look at what that looks like. X squared plus 11x plus 30. So the idea here is that here's my trinomial. I have three terms, and I want to turn it into a pair of two terms. Now notice how similar this looks. I just wrote down, let me get my highlighter out so that I can show you guys. Notice how similar this setup looks to this up here that we did when we were factoring 30. So again, we're just trying to break down what we started with. In this case, we're starting with x squared plus 11x plus 30. We're trying to break it down into things that can be multiplied together to get what we started with. Oh, let me get rid of these yellow circles so we're not confused. So the key to factoring a trinomial into a binomial is we have to think that if we were to multiply this together to check our answer, we would basically be foiling it, right? We'd have to multiply the first terms together, the outer terms together, the inner terms together, and then the last terms together. So we have to figure out what terms we have to put in both sets of parentheses so that we end up getting back to the x squared plus 11x plus 30. The first part is actually fairly easy. We know that this x squared, to get x squared, we have to multiply x by x. So I'm going to put an x right here and an x right here. That way when I multiply the first terms together and my binomials, I get x squared. And then these last terms have to multiply to give me 30. So that way when I multiply the last terms, when I'm foiling, I get 30. So let's think about the numbers that we could multiply together to give me 30. I could multiply 3 times 10. That's a multiplying, not a subtraction. Or I could multiply 5 times 6. Or I could do 1 times 30, right? So now we've got to figure out which one we want to choose. It's important that we choose the right pair because only the right pair is going to give us that 11x in the middle. So we want to choose whichever one of these pairs of numbers that multiply to 30 add up to 11. So 3 plus 10 is 13, 5 plus 6 is 11, and 1 plus 30 is 31. So this right here, this 5 and 6, those are multiplying to give me 30 and adding to give me 11. So those are the numbers that go in right here. With this one, we're just dealing with positive numbers. We'll look at an example in a second that kind of throws in some negatives and makes us think a little harder. But this one, we've got only positives happening in the trinomial, and then we have positive numbers down here in the two binomials. So this would be considered, this is, let's actually a different color for that. So this is factored form. Factored form. And if you remember, this top polynomial is in standard form. So factoring is how we go from standard form to factored form. And both of them are useful for different things, and we're going to take a good look at the ways that factored form is really, really useful for us. Okay, let's take a look at another one that has a negative in it. Might be a little bit trickier for us. So m squared minus 8m plus 12. Okay, so we have a trinomial, and I am going to try to turn it into two binomials being multiplied together. So again, I know my first terms are going to be m and m, because those are the two things that when I multiply the first terms together, I get that m squared that I started with. Now to decide what goes in my last slot, I need to think of what I can multiply together to give me 12. I could do 1 times 12. I could do 2 times 6. Or I could do 3 times 4. Okay, so let's add these up and see if we get 8 with any of them. So if I do 1 plus 12, I get 13. 2 plus, whoops, that is an 8, not a 6. 2 plus 6 equals 8. 3 plus 4 equals 7. Okay, so I notice that this 2 and this 6, they give me 8. And that is almost what I want, but I don't actually just want an 8 right now. I need those numbers to add up to a negative 8. So this is not quite going to work. But if I just change the 2 and the 6 to negative, if I do negative 2 plus negative 6, I get negative 8. So that's great. And if I do negative 2 times negative 6, I also get a positive 12. So I can actually use negative 2 and negative 6 as the last terms in this, as the terms in these two binomials. So here's a chance where we had positives and negatives happening. Okay, let's look at one example that seems nice, but is going to give us a little bit of trouble. So let's look at t. Actually, I'm going to choose a different variable. My t's always look like 6's. Let's choose s squared plus 6s plus 6. Okay, so let's just start it the same way as the other one. So I'm going to end up with two sets of parentheses. First term of both is going to be an s. Now I have to come up with two numbers that are going to multiply to 6. So I can multiply 1 by 6 to get 6, or I can multiply 2 by 3 to get 6. Those are my only choices for whole numbers, integers. Now if I add 1 and 6 up, I get 7. If I add 2 and 3, I get 5. But I really needed to add up to give me 6, right? So maybe we could think about maybe changing the 1 or the 6, or both the 1 and the 6 to negatives or positives. But no matter how I change these four numbers, these two sets of pairs, I'm never going to be able to add them up to get 6 like I need. So we would say that this trinomial is unfactorable. It is a prime polynomial. If you remember what a prime number is, a prime number means that it can't be the number can't be divided by anything except for 1 in itself. Same definition with a prime polynomial. It means that we can't factor anything out of it, so we consider it prime. So when you guys are working on your homework and stuff, don't expect every polynomial you encounter to be factorable. Sometimes you're going to get one that might be unfactorable. Okay, one more example I'm going to throw at you guys. I'm actually not going to work it all the way through. Oh, that's the wrong one. I just want to show you guys one example that you might run into. So say I gave you this polynomial. Looks pretty nasty right now. For one, with all the other ones you've been working on just barely, hasn't been a number in front of the thing that's being squared. So with this one, the first thing you would want to do is factor out the greatest common factor. So I'm going to factor out a 5 from each of these terms, a negative 5, which leaves me with g squared minus 5g minus plus 6, right? And now I've got the greatest common factor already pulled out, and then I've got a a polynomial that I can factor.